Thank you, Nicolas. Hello, everyone. I will make a small introduction before the kids. So I am Anthony. I'm the co-founder of Backoffice, which is kind of new, in fact 2 years old, research journal about the relationships between graphic design and digital practices, which is the kind of topic of Grow Paris, in fact. So we made with Spintank and Nicolas, and we thought that it was a good idea to work together. So what is Backoffice? So it's a journal. We have 2 issues. It's a yearly journal, and the first issue was released in 2017. It was about the making with about the process on art and design project, about the processus. And the second issue was released in May, some months ago, and it's about data visualization. And the journal is both print and digital. I have a few copies here if you want to see it. And in fact, we are still looking for sponsors. So if you are an agency, a school, or whatever with money, I am interesting. It's the same problem than Nicolas talked yesterday about the Grow event. The journal is it's a research journal, but it's also a pedagogical tool. So we have things like that. It's a bilingual glossary. I think you know most of the name, but everybody not. So it's very helpful to have that kind of things online. I will present Backoffice tomorrow with my colleagues to see it in details. So the New Kids contest, it's a kind of new version of the New Kids contest, because that year we have a subject. Last year it was a kind of free showcase. So with my colleagues in Backoffice, we wanted to have some of consistency with the presentation. So we asked the students to work with a dataset of postcards. It's a postcard of Brittany in France. And it's interesting because it's old materials, and we have also the recto and the verso. So we thought that it was a good idea to work with. We made a spreadsheet with all the data available for the students, and so there is no other things to know. The students can do whatever we want with the postcard dataset. So we received some very interesting projects, and we select 3 of them today to be on stage with you. Thank you very much. So we will start with Guillaume Slizevich.
Yeah, that's almost it. Slizevich. So hello everyone. So this is what I'm talking about. So wow, this is a really good quality GIF. So just using the lib to control sonic, those kind of experiments, using a t-SNE algorithm to cluster images. So basically what it does, it's an unsupervised algorithm, and it finds the similarities between images, and then it clusters them together. I mean, it calculates the proximity between them, but it's on many dimensions, but then it outputs it in only 2 dimensions, so we can be able to enjoy it fully. And then I started as well working with object detection, and you can see it on one of the postcards. And this led to one more recent experiment. Oh no, first with Jen from Glasgow School of Art, we kind of thought about those algorithms that are becoming ever more present, and how to use them, to misuse them, and to use them in different contexts. So to use them for things that they're not trained for. And this is why we tried to run an object detection algorithm, which is trained on a lot of different objects, but in normal context. We trained it. We tested it on flags, on a data set of flags, and most of the results were quite insignificant, but some were more interesting. And so I continue. I try to continue using this object detection. I find it really fascinating. And with my team in Brussels, we think about how we're gonna live with those algorithms, and especially with the objects that are becoming semi-autonomous, that have some kind of intelligence. They're not completely intelligent, but they have some kind of intelligence. And how we're gonna share space with them and share public space with them. And we also like to put that in parallel with the animal extinction, so wildlife extinction. And it's as if we were replacing natural wildlife by electronic wildlife. So one of our more recent projects is introducing electronic wildlife. So we made a small robot that is actually that can detect a person and go towards it. And this runs the same algorithm, so object detection, and it can see where you are and move accordingly. In the long term, it's going to be in the street, but right now we are still trying it out in the workshop. So you can see it here. And what's interesting is that it's all in local, so it's all running on a Raspberry. It's not there's no connection and like a bigger computer running it. And we try to see how we can have empathy with those machines as well, and how we can live with them, and what is going to be the impact. So it's more of a speculative design work, but it's fun. So I use those tools, and I try to have new ones when working on the project with the Data dataset. And I really wanted to try out GAN. I think Mario talked a lot about them, like generative adversarial networks, which has neural networks, which are a type of algorithm that generate themselves features. So they analyze themselves the data, and they output things that we are not completely, so it's not rule-based, but they're learning by themselves. So it's really machine learning in the truest of sense. And this is the data that was given to us. So what's nice is that's a really clean data set, and it's really orderly, so which is rare and which is nice. The only problem it was only 300 photos. So it's not a lot to run a machine learning algorithm. It's a bit too few. The way I did it is I scraped all the data with a Python script, then I augmented it with, you have some cheap tricks that you can use to augment your data. So one of them is just flip them horizontally, especially for this data. So because the algorithm has no idea that it can flip them and it's going to be the same image. So if you flip them, you have double the data set. And then if you do like small zoom and de-zoom, you can have like more and more. So I ended up with like 800 pictures, which is not a lot, but it was worth a try. Oh yeah, and I just want to point out that most of the algorithms that I'm going to depict there are quite resource intensive in terms of computing power and time. So I didn't have the time to really process all of them. So some of the images are going to be super low res. I'm really sorry about that, but I don't have the money to have a super strong computer. So these are the first two algorithms I tried. So one is CycleGAN, which is a bit like a style transfer, but it takes a full data set of one type, one style, and a full data set of the other. And then you can do a switch between them. So apply one style to the other data set. And the other one is DCGAN, which is a generative network that you feed it a lot of data, and then it outputs something that is similar according to itself. So the CycleGAN you can see it here after only 30 epochs. So I took a Monet dataset, so Monet the painter, and I trained it on Monet and the postcards. So what's quite cool is you can see after only 30 epochs, the algorithm already detects the kind of the texture and the colors, which is nice. It's a bit less successful with postcard to Monet. It doesn't really look like a Monet painting, but that's a start, I guess. And the DC GAN. So the DC GAN was quite tricky. So here you have 64 images that it produced. And I was thinking, watching the previous talk, that it really looks like Berlin noise as well. So it doesn't really detect the feature at this point, but it wasn't trained really long, this one. And then in the end, I used the progressive GAN, which is a model that came out this year, and is super, super cool and effective. It's really a hassle to install it because you have a lot of dependency, and it took me maybe 2 days. But once you install it, you're really happy. So those are the pictures that were given, and you have to kind of square them and so on. This is the noise it outputs, and then the algorithm will try to maximize the feature and to make it look like an image that would be similar to a postcard. And here you have the GIF of a GIF of the neural trying to figure out the features and growing by itself. So at first it's really like pixels, and then little by little it's becoming more and more smooth. And then you start to have latent landscapes, things that are not. It's really quite fascinating the way. So this was, I think, Saturday. It's still running as we speak. So this was Saturday, and you can see here, it's one of the bridges that was on the dataset, and it appeared on many images. So you can see it again here. And here you have like more normal landscape from Brittany. And here I think it really looks like a crowd or something. This was, I think, Sunday, and I really love this one because I don't think there are any nudes in the dataset, but somehow it looks like it's a naked woman lying on a bed or something like that, and it's really weird that it started from the bridge and ended up there. And what's nice as well, it detects the stamps that were on some of the postcards, and of course the writing. So since I flipped the postcards, you wouldn't have like legible writing, and you wouldn't have like thing that looks like letter because they would be in both in normal and reverse. And this is, I think, this morning or not too long ago. So what's really funny, it reverted from this kind of woman to a bridge again. Yeah. So that was it. That was the output that I got. If someone wants to buy it for $400,000, please feel free. And I think that's what's really interesting in those algorithms. It's how we can use them in different contexts and how we can use them with different data sets and exploit the glitches and try to use them with like smaller data set to see how it reacts and so on. So if you're interested, ML4A by Gene Kogan. And thank you very much for your attention.
Okay, so hello everybody. So first of all, we would like to thank you all for coming, and special thanks to the Grow and the Backoffice to give us the opportunity to show our work. We all come from Gobelin. So Nikita, Jean and myself were focused on the development while Mathieu was on the design. So it's been a while since we had been thinking about making a 3D video game on the web. So we told ourselves that it could be cool to do it for this event. So we gave it a try.
Our experience is called La Sonde des Souvenirs, and it's a desktop platform game. you control in this game the consciousness of Pierre, which is lost in its spirit because of a crazy night in Saint-Brieuc. And so your goal is to find your memories, and your memories are symbolized by postcards. You can find one postcard per platform, and the position of the platform has been generated with the dataset that was provided to us. And so with all of this, it allowed us to generate 29 steps itinerary. And now it's the time for the demo. So you can all clap your hands for Nikita, because it's going to be quite a challenge. If it works.
Okay, so first a little introduction. It's in French, sorry. Sound, please.
Et merde, encore toi.
It's good.
Waouh, je vois triple. Cette soirée, une dinguerie. Attends, mais qui me parle? Ton esprit, du con. Tu crois que tu es où? Et comme d'habitude, tu ne te souviens de rien. C'est pas la première fois que tu te retrouves ici après avoir bu 3, 8, 6. Espèce de fragile. Oh, le bad. On dirait ma voix. C'est quoi ce délire de schizo? Le délire, c'est que tu t'as encore mis une grosse mine, l'abruti. Et que t'es en train de perdre connaissance. Alors si tu veux sortir d'ici, t'as intérêt à retrouver ton corps et fissa. Sinon, toi et moi, on va disparaître aussi vite que le contenu des shots que tu viens de prendre. Alors grouille-toi avant qu'il soit trop tard. Oh, oh, l'embrouille. Oh, mais où j'ai atterri, moi?
Okay, go on, Nikita. So first, Nikita have to pick up the card to unlock the way to the next island.
J'ai intérêt à me grouiller.
So the character going to say random thing or specific thing about the card which is picking up.
Sacrément vide la place de la préfecture à cette heure-ci.
Un petit peu, ouais. Un petit peu. Ça va, ça va. So we are helping the user with rotating the camera in the right direction when they picking up a card. A card, sorry.
J'ai vomi ici, ici aussi.
Okay, go on. Okay, Nikita, go on, go on.
Je crois me souvenir qu'un mec est passé en vélo ici.
Don't forget that Pierre is a little bit drunk, so the effect's gonna reverberate.
Vive la
on the
Bretagne
screen.
libre! À partir de ce
And
moment-là,
that's
tout
it.
s'est mis à tourner.
He's good.
Putain, tu te rappelles vraiment de rien?
Okay, you're going to let Nikita enjoy the game.
À partir d'ici, c'est devenu difficile de tenir debout. Carrément badante l'allée des grandes promenades.
Oh, he died. So this is the game over page. You're probably going to see this page a lot of time. So on this page, you can restart the game or just see the different memories. Sorry, that Pierre spent the last night. So under each card, you're going to have a little sentence who allow us to know what Pierre doing and the last night was very difficult for him. T'as pas quitté le site. Quitte le site. And go back to the presentation.
So regarding the design, we chose the low poly aesthetic because I began to learn 3D for this experience, and because of the timing. And for the general atmosphere that you just seen, what we wanted was to make feel the player that he was in the Pierre spirit, and that he was in a very wide, boundless and aerial area. For the character, we wanted him to have kind of phantomatic appearance, and we modeled several assets to show what the crazy night of Pierre had been. So these are the assets of the game. And we've worked also on the four animations. So this is the running animation. This is the animation when he's falling. It hasn't been implemented yet, but maybe soon. And this is the jump animation. Beautiful. And finally, the idle animation. The idle animation is when the character is not moving.
So for the project setup, we wanted to have only one page to handle. We decided to work on a framework. We chose Next.js. We wanted to avoid too long loading times in the scenes. So we choose this framework for different reasons. Clarity, convenience, but also clarity, habit. So we had a nice setup for different components without them to interfere with each other. Which is cool is that it loads Vue and Vuex that we needed for the game state management. For example, to know how many cards we picked, to know the timer, or for the data management at the level of the cards for the end screen, for example. By the way, it also allowed us to do server-side rendering pretty easily. So we could have an isomorphic application and therefore much faster rendering. We also used 3JS. We had already done several projects with it, so it was the library that we knew the best. But also it was the library that allowed us to implement the different elements like the character with the rig, the shadows, or the lights. Finally, we go on Canon.js because it's a lib that binds very well with 3JS, and also it allowed us to have a relatively simple management for the physics for our needs in this project.
Okay, so for the position of the island, so we used the title of the card from the data provided. So thanks to the Google Map API, we succeed to find 55 of them, but for our experience, we decided to keep only 29. So like we have already said before, we transformed the geographical coordinates to Cartesian coordinates to use them in a 3D environment. Concerning the cloud, so we use a method on the GDC talks made by John Lelove about the VFX effect of the Diablo game. So this method consists to, in GSL, take one texture, zoom into it to create two other one, and the last one represents a mask. So by multiplying and combining all of those textures, we succeed. And sorry, I just forgot. By passing the UV, by passing the time parameter to the UV and multiplying all of this texture, we succeed to have this generative cloud. So this result was applied on 20 planes. Those planes are always facing the camera, and they are always following the movement of the character. For the sea, we use in GLSL a normal map and a displacement map, and we just animated the vertices of plane with passing a time parameter on our UV.
So for the character, that was one of the main parts of the project. So we exported it as an FBX file to be able to easily get the skinned mesh with bones and all in 3JS. And we had to create a custom character manager, so it would be easy to do transitions between the different animations. So there's a camera that's following the character, and so you can move around it, and also so it can give the direction in which the character must go. And that was quite a tricky part because we had to recalculate on the run the velocities according to the rotation of the camera using quaternions. And for the ghostly effect of the character, for the ghostly effect of the character, what we do is we calculate the dot product between the camera position and the vertices of the character. So we have that kind of effect. For the post-processing part, we kind of recreated our own effect composer from 3JS. So we would have the hand over it, and so it would be easy not only to implement post-processing on the scene, but also to change scenes with animations on it. And so the post-processing that I used on this on the game are an FXA pass and also a grain pass doubled with the drunk shader pass, which is toggled when needed. For the islands, so we exported everything as GLB files for better compression, and every island is different. We have different models for the islands. Every objects on it are different too. We're at different scales, so every island looks different. And since we had to focus also on performance for the little orbiting rocks around the islands, we used instances. So we were able to draw a lot of elements, but in a single draw call. For the postal cards, we kind of tried to do a VFX effect with the aura around it, and for the cards themselves, we use a sprite map to create only one texture and do only one request to the server. And for the physics of the game, we only used simple geometries, simple bodies from Canon.js, so it will be easier for the CPU to calculate collisions. And also, we remove the bodies once we don't need them to gain in performance.
Finally, for the sound, we recover the voice-off. Then we cut each sound into small chunks in order to trigger them according to the event file. For example, the jump, the picking of a card, or the defeat. For the introduction, which is synchronized with the voice, we cut the text into several parts. Each part of sentences have attributes such as beginning, end, duration, and according to the current time of the audio, we pass inactive the current sentence, the sentence which is stated, and we handle the scroll depending on this current sentence.
So thanks everyone for listening. We hope you'll be soon try to reach the 29th platform, and now let's drink.
Hi, hello everyone. So this is Jade, Solal, Julien, and I'm Bastien. And we are going to present you our project about Saint-Brieuc. And it's about postcards and Brittany and the past century. So there's this big database of postcards that we got. And when we saw them, we asked ourselves, OK, how to link those postcards with contemporary experience in 3D, and how to link them, make a bridge with the present. So we decided to make a map, a 3D map in WEBGL. So the goal was, this is not only one postcard. You got a set of postcards, and we wanted to create a place, context for those postcards, and we wanted them to highlight their richness. But enough chit chat. Let's see the project. Yeah. So, you got a little introduction that for the context, for the story. There is postcards from the past. They come in saint-brieuc. You got a little skip button, but I'm not gonna click on it. Just wait for the loading. And whoa, little cards floating in the air, yeah. Chilling, just there. And we can enter. We got little birds, and yeah, obviously this is the map of saint-brieuc. You got a little tutorial, you can click to navigate, okay. You can drag, and if you want, you can have like a little global view of the map of saint-brieuc. And it tells them to find the postcards. And you got at the top, if you see, a little compass that tells us where they are. And I think I see one here. Okay. Oh, postcard. Rue Fardel. Nice. I think here we are in the downtown. Yeah. Okay. Another one. École des Garçons. And I can go back, and there is little messages sometimes, but you know, no messages. Okay. Another one. Let's walk a little. Let's go. Oh, there's a bridge here. Whoop. Yeah, and you can see like we recreated the point of view of where the card was, the photo was took, and we locate the postcards. With sometimes the name with OpenStreetView, but sometimes with the Wikipedia API, because some monuments doesn't exist anymore. And you can also like, oh yeah, there is some messages. And for the city, we took it from OpenStreetMap data. And oh. And we got, I've got too far. Where am I? I'm lost. Qu'est-ce qu'il y a? Oh yeah, the collection. So when you gathered those card postal, you can see them and just enjoy looking at those beautiful card postals. Well, up.
So, peu fort ça. How we made the city? It's very challenging to rebuild a digital version of saint-brieuc, particularly when you have a short deadline, technology constraint, and precise geolocalization in mind. But what was our pipeline to craft this? When we finally achieved to export the right amount of data from OpenStreetMap, we meet another issue. How are we going to convert OSM file in a viable format for 3GS? It was a long journey of back and forth between Cinema 4D, OCM, Draco, and Tree. In order to have suitable performances, we split the ground and the city into 9 different tiles. Like that, we can only load what we need to see. An absolute feature if you want to keep up the FPS high.
At the beginning of our experience, we display a cards cloud waving in the sky to create some mysterious atmosphere. And since we have an important amount of postcard, we made up a tiny PHP script which downloads all the image from the Google Sheet, normalizes into JSON, and generates a single sprite map with all the cards. With these assets, we instantiate the cards cloud with an instance buffer geometry, and we animate it with 3D noise to make the cards moving smoothly. Noise and to get this shape where there is more cards in the middle of the cloud, we use a Gaussian distribution in the right. Now we will talk about environment and how we improve the rendering of the city thanks to vegetation, relief, weather, and sound.
So first, let's talk about this texture. So in order to store all the environmental data we need, we create this single texture to manage vegetation, water, heat map, and to avoid to load too many, to send too many requests to the browser at the loading of the page. So, for example, to create the relief in all the city, we map in all the vertices of our scene, and we convert it to 2D codes, and we are gonna compare the value with the blue value of this texture to create an heat map. So, for the vegetation, we generate a lot of random position in our texture, and for all this position, we compare it with our green channel in our previous texture, and we compare if the green value is big enough. It means that we are in a vegetation area, so we store the location. At the loading of the page, we load this single tree and all the location, rotation, and scale of all our trees, and we create this. Now, we thought our scene was lacking of birds. So we create an instance geometry to generate all these birds. So it is a simple plane, and we map on it this texture as an alpha map. And we use the X coordinate to create a regular wing flapping, and then an instance geometry to create random position, animate separately all the birds. Now it's time to add sound. So to create an ambience which match with the camera's controller we add, we create a small spatialization system to select a sound in function of the altitude of the camera. So you can see on the graph at the left that the higher the camera is, the higher the sound of the sky will be important, and at the inverse, the sound of the floor will be less important.
Thanks to the way we split the map, as told earlier, we were able to create a much bigger shadow map related to each tiles. To achieve this blend, shadow, and ambient occlusion map, we bake it from Cinema 4D, and to be more precise, with Octane Renderer. Let's talk a little bit about the buildings. After we finished the city of Saint-Brieuc, we felt that the OCM data we got was not good enough. And to create a real link between the postcard from another century to our contemporary representation of Saint-Brieuc, we build on top of the city a selection of key buildings that you have here. In order to keep the same realism of our map, we also did for each building the UV unfolding and baked the required textures.
So, thank you for everything.